Hey, thanks for joining me. We're going to attempt to solve this proportion. It looks like a really complex proportion when we do the cross products. You multiply the numerator here, 3x, by the denominator here. It looks like we're going to get x times x, which is x squared, which means we're going to have what we call a quadratic equation. We're going to have x squareds in there, which is going to be a little bit more complicated. If you have taken an Algebra 2, you probably know how to solve those. If you've only done Algebra 1, you might be a little iffy on those. But good news, before we take that step of cross multiplying, we're going to just take a look at each ratio. So this one, 3x plus 7 over 5x minus 8, I don't see any way we can reduce that. But the first one, 3x over 4x, well, that one has common factors in the numerator and denominator. Factors meaning things multiplied together. So 3 times x, 4 times x, both times x, so we can cross the x's out. And that's going to make this a lot easier. Now when we do our cross products, we're going to get answers that don't have x squared in them. So cross product 3 times 5x minus 8, we'll write that down, equals, and then the other across 4 times 3x plus 7. And notice that I'm showing my work, I'm showing what I'm doing here, because I don't want to make any mistakes. And it'll become clear a little bit later on why I don't want to make any mistakes. I'm going to distribute. So I didn't distribute first. I wanted to kind of show what I was doing. So 3 times 5x minus 8 is 3 times 5x is 15x. 3 times negative 8, that's 24. And then distribute 4 times 3x is 12x. And 4 times 7 is 28. And now I'm going to solve this equation by getting all those x's on the same side. So there's 15 x's on the left, 12 on the right. I'm going to subtract 12x from both sides. It's the addition property of equality, or subtraction property of equality. That's going to get rid of all the x's on the right-hand side. And since I'm going to do that, I might as well get rid of all the non-x's on the left-hand side. So there's a minus 24 there. I'm going to add 24 so that I get all of my numbers without x's on the right-hand side. All right. Combine like terms. 5x minus 12x is 3x. And 28 plus 24 is 52. Finally, the last step in solving this equation is going to be to divide by 3. And we find that x equals, now this is, going to be careful here, x equals 52 thirds. If I type this in my calculator, I'll get an answer, but it will be a decimal answer, and it will actually be a repeating decimal. Whenever you divide by 3, if it doesn't come out evenly, you end up with a repeating decimal. So it's better to leave this as an improper fraction. In fact, we're going to say this is the best answer to this solving this proportion. I'm going to show you that this is true. I'm going to take this right-hand side proportion. Remember, on the left-hand side, we have 3/4. And so if I can make that right-hand side a proportion equal 3/4, then I know that I've done this right. Now, before I do this, you can stop now. We're done. This is the answer. This is how you do these problems. And I'll point out that if you don't want to check your answer, which is always a great idea when you're solving for x, just plug it back in and see if you got the right answer. If you don't want to check your answer by solving, by plugging your solution back in, then you want to make sure you do a really good job and don't make any mistakes. And that's what I did here. I showed every single step, and I was really careful with this so that I was reasonably sure I didn't make any mistakes. But I'm going to just real quickly show you that we can check our answers even when it's something ugly like this. So I'm going to plug in my answer, which is 52/3, in for x in both equations. And then we're going to, let's see, we'll multiply. So 3 times 52/3, well, the 3's cancel, and we're left with just 52 plus 7. Okay, that's the top. Now, 5 times 52/3, well, that's not going to cancel. So I'm going to have to do 5 times 52, that's 260 over 3. Minus, now I need to turn this 8 into thirds. So 8 times 3 is 24, so minus 24 thirds. All right, so on top, 52 plus 7 is 59. And on the bottom, 260 thirds minus 24 thirds is 200, and let's see, 60, 50, 40, 36 thirds. Now if we're going to divide by a fraction, we just multiply by the reciprocal, so this is 59 times 3 over 236, and we end up with, well, 59 times 3, if it's 60 times 3, would be 180, so this is going to be 177. Now, that looks exactly like 3/4, right? Well, not really. But let's see if we can reduce this down a little bit. So I have 177 over 236. And the question is, does that equal 3/4? Well, one way to test this is to say what times 3 equals 177. And we can do that. I'm going to, I'll use my little calculator here. Call it long division. Divide by 3. Okay, 5, 15, 27, that's 9. So 3 times 59 equals 177. So if I divide 177 by 59, I get 3. So if I do the same thing on the bottom, or I could work it backwards, I can say, well, does 4 times 59 equal 236? 4 times 59, and that's, let's see, 36, 20 plus 3, oh, looky there. So 4 times 59 equals 236, so therefore 236 divided by 59 equals 4. So even though this is a really big, ugly fraction, you can see that it can be reduced by dividing the top and bottom by 59 down to 3/4. Therefore, it equals this other ratio here, 3/4. And so this proportion is correct if you plug in x equals 52/3. Crazy, isn't it? Now, again, I'm not recommending that you check your answers on these ones because it's just way too much work and too many opportunities for mistakes here. I just want to show you could. In this case, you just need to be really careful with your work because you don't want to make a mistake, get an answer like this and say, I'm too tired to check it. You want to make sure that there's no mistakes. All right, thanks for watching.